Hello and welcome to this lesson on cleaning our customer dataset. In this lesson, we'll be focusing on cleaning the customer dataset we had optimized in the previous lesson. Our goal with this lesson is to learn various data cleaning steps in order to get the data ready for analysis. Data cleaning methodologies vary from dataset to dataset. However, this lesson will give you a clear idea about the things you should focus on and also the things you should try to ignore when cleaning data. So let us start this lesson off by importing the necessary libraries, and for this lesson we'll only be importing pandas to work with data frames. So here I'm importing pandas as PD in Python by writing this line of code. I'll run it and make the import happen. Next, let's import the CSV file called optimizegstoredata.csv, which contains optimized information about each user's website visit along with the revenue they generated for Google. So for that, I'm calling the read_csv method from the pandas library and I'm specifying the file path as data/optimizegstoredata.csv, and I'm also setting the property low memory equals to false since some of the columns have mixed data types in them. Then once this data frame has been read in, I'm assigning it to the variable store_df. So I'll run this line of code and make the assignment happen. Okay, this will take some time since the data file is quite large. Next, let's look at the first 5 rows of the data frame. So we're using the head method and we're calling it off of the data frame. So if I run this, we have our data frame over here. And we have 35 different columns with 5 different rows being displayed over here. So as a first step in our data cleaning process, let us standardize our date and time columns by converting it into pandas datetime format. This will help us use pandas ready-made functions as needed in the future. So we have the date column over here and the time column over here. So let's start with the date column. So we can check the data type of the date column by simply selecting it and passing in an index or the value that we want to select. So for now, if I just comment this out and if I just write store_df date and 0, we get the first value which is over here at index 0. Now if I check the type of it, we can see that it is in an integer type right now. So let us convert this into a string and then let us extract the year, the month and the day from this string and finally convert it into a datetime value. So for that, I'm converting the entire column as a string by using the asType method and passing in the parameter str. Then I'm assigning the string converted values to the date column again. So if I run this and if I check the type again, we can see that it will be a string. Okay, now we can get the year. So for example, if we have store_df date 0 over here, since this is a string, we can use index slicing on it. So if we want to select only the year, which is up to the 4th value, we can write :4 over here. So this will give us 2016. And we can do the same for the entire date column. So over here, I'm calling the apply method off of the date column and we're using a lambda function here. So for each data value given by x, just select the first 4 digits. So if I run this, we can get the year values for the date column. Similarly, we can get the month and the date by selecting those respective indices from a string. So again, if we check our string over here, we can get 09 by just selecting 4 to 6th value. So if I run this, we get 09, and for the day we can just select 6 colon and we'll get 02. So I'm doing the same here for the entire date column as well by using the apply method and passing in a lambda function. So for each date value, which is a string right now, select the first 4 digits, then the 2 digits after that, then all the digits after that, and separate them out by using a dash symbol. So if I run this, we get the year, the month and the day. So now we can reassign the new panda series, which is this series, to the date column, So for that, I'm just writing the code as before, then I'm assigning it to our date column, which is the string column we had made over here. So if I run this and if I print it out, we can see that the date column now holds the date values in a datetime format. But right now, the data type is still an object. So let's convert it into datetime. For that, we can call the to_datetime method off of the pandas library, and we can pass in the date column as a parameter. Then we can assign this date column again to the column itself in order to replace it with datetime values. And right now, if I run this, we get the date column in this format. And if I just print out the date column itself, we can see the data type is now datetime64 and s. So next, looking at the visit start time, we can see it is in Unix format. So this means that we have to convert the time to a local time format depending on each city or country. Doing this is a very lengthy process, and since I know through my own analysis that the time column isn't very helpful for predicting revenue, let us just drop it for now. However, if you are working on a use case such as fraud detection, I highly recommend that you put the effort to standardize the time column, since it will be helpful in such use cases. I'll leave you with the workflow to do so for now. First, convert the time from a Unix format into a UTC format. Then, change the UTC time to a local time based on the city or country. Finally, extract the hour, minutes, and seconds of the day. You can also account for daylight saving times to be highly accurate. Now, next, let us take care of the null values in our dataset. So if I just print out the head of the dataset for now by writing store_df.head, you can see that there are a lot of null values over here, and we must take care of them before we do any kind of analysis. So in order to check which columns have how many null values, we can use the isNull method and followed by the sum method on our data frame. So if I run this, okay, we get the count of all of the null values in all of our columns. So starting off, we have the page views columns with 100 different null values, the bounces columns with about this much null values, and similarly so on. So there are a lot of columns with null values, as you can see, and let us look at how we can fill these null values with actual data using statistical reasoning by going through the columns one by one. So let's start with totals.pageviews, since it's the first column on our list over here containing null values. One helpful way to fill in the null values is to fill in the data as the most repeated value in the column. So for that, we can use the valueCounts method to count the number of unique rows in the columns. So we're selecting the column as totals.pageviews from the store_df data frame, and we're calling the valueCounts method off of it. So if I run this, we can see that most of the page views are 1, since there are about 452,522 different page views being recorded as 1. So simply, we can just fill in the null value as 1. To do that, we can use the fillAnA method and pass in the value that we want to fill for the null values. Then we can set the inPlace property as true to reflect the change in the dataset itself. So if I write in this line of code, it will convert all of the null values into the value 1. And since all of the data values in the columns are float, the column or the data value over here will automatically be converted into a float value as well. So what we want to do is we want to store the total page views as an integer, since it makes sense to have this as an integer rather than a float. So once the null values have been filled in, we can convert the data type into an int by using the asType method and passing in the parameter as int and specifying that the total page views column will now be an integer. Okay, if I run this line of code, the null values should have been filled. So let's do the same for the bounces column. So I'm printing the counts of unique rows in the column totals.bounces by using the value counts method off of it. And as you can see, all of the values are 1. One good explanation of why all of the data values is 1 may be because the null values are actually zeros. So therefore, we can fill the null values as 0 for the bounces column. And again, I'm storing it as an integer. So I'll just run both of these lines of code in order to fill all the null values in the bounces column as 0 and then convert it into an integer data type. So I'll run this and the null values have been filled and the data type of the column has been changed. So let's follow the trend for transaction revenue. So I'm calling the value underscore counts method off of the transaction revenue column, and if I run this, we can see that the values are not repeated in any way, but what we can guess is that the revenue values which are actually null in the column may be 0 since all of the values have some kind of repetition in them. So for that, we're filling the null values at 0.0, and since the transaction revenue can actually be a float number, we're leaving it as it can be. So over here, I'm calling the fillANA method off of the transaction revenue column. I'm passing in the filling value as 0.0 and I'm putting it in place, which is we want to see the changes reflected in the original dataset. So I'll run this and the null values have been filled in. Next, let's look at traffic source is true direct. So we're calling the value counts method off of it. And again, we can see that it has a boolean true, which is almost 274,000 times in the dataset. So the null values must be false since only the direct traffic source values have been recorded. So again, I'm filling the null values using the fillANA method and I'm passing in the filling value as false. So if I run this, the null values will be converted as false. Now we can fill up the null values in all of the remaining columns as we have done till now. So you must have got an idea about how you can actually fill null values by considering different cases in the dataset. So I'm running all of these fillANA values based on the information as we have already discussed over here. So you can look at all of these columns value counts and figure out why I'm filling out these values in these columns. But for now, I'll just make sure that all of the null values are filled in these columns. So I'll run all of these lines of code and the null values have been filled. So again, if I just print out the sum of null values for all of the columns in the dataset by using the code store_df isNull.sum, we can see that most of the columns have their null values already filled except some of these columns over here. So we'll drop the remaining columns since they are either very sparse or they cannot add any value to our analysis, or correctly filling the null values in them is very hard. So I'm calling the drop method off of the data frame and I'm specifying the columns which are over here and I'm dropping it in place. So this means I'm making the changes reflect in the dataset itself. So I'll run this line of code to drop the columns. And let's again see the null values counts. So now we have a very clean dataset with no null values remaining. So great, we've successfully completed the data cleaning process. Finally, let us export this clean data frame to a new CSV file so that we can use it in future lessons. So I'm calling the to_CSV method off of our data frame and I'm specifying the file path as data/cleangstoredata.csv, and cleangstore.data.csv is our file name. We're specifying the header as true and the index as false as we had done in the previous lesson. So I'll run this and let us make the export happen. So by the way, one last thing, if we look at the summary of the data frame by using the info method, we can see that a lot of these columns still have the data types as object, even though we converted some of these columns as integers or float. So as an exercise, I would like to encourage you to convert all of the data fields from the object data type to their own respective data type, which may be boolean, string, integer, float, etc. This would help to reduce the memory uses of the data frame and aid in cleaning the dataset even further. You can use the asType method off of the data frame for this. And once you've done that, you can export the new data frame with the CSV file name cleaned_gstore_data.csv and use it for further lessons.